Hey there, energy enthusiasts. Welcome back to our channel, where we're about to dive into an absolutely irresistible topic. In today's video, we're unlocking the secrets to creating an off-grid paradise with a battery bank installation that will leave you energized and ready to take on the world. Are you ready to harness the power of renewable energy? Well, get ready to be blown away as we guide you through the intricacies of mastering battery bank installation. Trust me, once you learn these secrets, you'll be able to power up your off-grid system like a pro. Imagine a location where you're free from the constraints of the grid, where you can create your own energy oasis. In this video, we're going to show you how to choose the perfect spot, protect your batteries like a fortress, and wire up a system that will have you saying, goodbye, electricity bills. But that's not all. We'll be spilling the beans on configuring your battery bank to maximize voltage and capacity, ensuring you have enough power to keep your off-grid lifestyle running smoothly. Plus, we'll share expert tips on battery monitoring, safety precautions, and regular maintenance to keep your system in tip-top shape. Get ready to geek out with us as we unravel the science behind solar performance. We'll break down the magic of photovoltaics, explaining how sunlight transforms into a renewable energy source that'll have you doing a happy dance every time you flip that switch. But wait, there's more. We'll demystify the jargon around voltage, amperage, and wattage, helping you understand the power behind your power. From voltage as electric force to amperage as flowing current and wattage as energy consumption, we'll have you talking electricity lingo like a seasoned pro. So, if you're ready to unlock the secrets to creating your off-grid haven, join us on this electrifying adventure. Don't forget to grab your favorite energy drink, sit back, and get ready to be wowed by the irresistible world of battery bank installation. Battery bank installation for off-grid systems involves several important considerations to ensure safe and efficient operation. Here are some intricacies to keep in mind during the installation process. 1. Location and environment. 1. Choose a suitable location for your battery bank installation. 1. It should be well ventilated and protected from extreme temperatures, moisture, and direct sunlight. 2. Ensure the area is clean, dry, and free from flammable materials. 3. Consider any specific requirements or recommendations provided by the battery manufacturer. 1. Battery enclosure. 1. If required, install a battery enclosure or cabinet to protect the batteries and provide additional safety. 2. The enclosure should be made of non-conductive material and have proper ventilation to dissipate heat generated by the batteries. 3. Ensure that the enclosure is securely fastened and provides sufficient space for battery maintenance and inspection. 1. Wiring and connections. 1. Use appropriately sized cables and wires based on the battery bank's voltage and current requirements. 2. Follow the manufacturer's instructions for wiring connections, including positive and negative terminals. 3. Use proper insulation, cable lugs, and connectors to ensure secure and reliable connections. 4. Implement safety measures such as fuses or circuit breakers to protect against overcurrent or short circuits. 1. Battery bank configuration. 1. Determine the configuration of your battery bank based on the voltage and capacity requirements of your system. 2. Series connection. Connect batteries in series to increase voltage. 2. Ensure that all batteries are of the same type, capacity, and state of charge. 3. Parallel connection. Connect batteries in parallel to increase capacity. 3. Again, use batteries with similar specifications and conditions. 4. Follow the recommended guidelines and consult with professionals to determine the optimal configuration for your specific system. 1. Battery monitoring. 1. Install a battery monitoring system to track battery health, voltage, temperature, and state of charge. 2. Use battery monitors or management systems that provide accurate and real-time information about the performance and condition of the battery bank. 3. Set up alarms or notifications to alert you in case of abnormal battery behavior or issues. 1. Safety precautions. 1. Wear appropriate personal protective equipment, PPE, such as gloves and safety glasses, when working with batteries. 2. Avoid short-circuiting the batteries by preventing contact between the battery terminals and conductive materials. 3. Be cautious of potential hazards such as battery acid, explosive gases, or electrical shocks. 3. Adhere to safety guidelines and consult professional installers if needed. 1. Regular maintenance. 1. Develop a maintenance schedule for your battery bank, including periodic inspections, cleaning, and testing. 2. Monitor battery voltage, temperature, and state of charge regularly to identify any abnormalities. 3. Follow the manufacturer's recommendations for maintenance and perform tasks such as equalizing, desulfating, if applicable, and replacing batteries as needed. 1. Documentation. 1. Keep detailed records of your battery bank installation, including wiring diagrams, equipment specifications, and maintenance logs. 2. Document any changes or modifications made to the battery bank over time. 3. This documentation will be valuable for troubleshooting, system upgrades, and future reference. It's crucial to follow safety guidelines and consult with professionals or qualified installers when installing a battery bank. They can provide expert advice, ensure compliance with local regulations, and help optimize the performance and longevity of your off-grid energy system. Let's unpack the jargon related to voltage, amperage, and wattage. 1. Voltage. V. Voltage is a measure of the electric potential difference between 2 points in an electrical circuit. 1. It represents the force or pressure that pushes electric charges, electrons, through a conductor, such as a wire. 1. The unit of measurement for voltage is the volt, V. 1. In simpler terms, voltage can be thought of as the pressure of electricity, analogous to the pressure in a water pipe. 1. Higher voltage means a greater potential for electrical flow. 1. Amperage. A. Amperage, also known as current, refers to the rate of flow of electric charge in a circuit. 1. It measures the quantity of electrons passing through a specific point in the circuit per unit of time. 1. The unit of measurement for amperage is the ampere, A. 1. Using the water analogy, amperage can be likened to the flow rate of water in a pipe. 1. Higher amperage indicates a larger quantity of electrical charge flowing through the circuit. 1. Wattage. W. Wattage is a measure of the rate at which electrical energy is used or produced. 1. It indicates the amount of power consumed or supplied by an electrical device or system. 1. The unit of measurement for wattage is the watt, W. 1. Wattage is calculated by multiplying the voltage, V, by the amperage, A. 1. This relationship is expressed by the formula wattage, W, equals voltage, V, x amperage, A. 2. Wattage is often used to determine the energy consumption or power rating of devices such as light bulbs, appliances, or solar panels. To summarize, voltage represents the electric potential difference, amperage measures the rate of electric charge flow, and wattage indicates the rate at which electrical energy is consumed or produced. Understanding these concepts is important for designing, sizing, and troubleshooting electrical circuits and devices. The science behind your solar performance. Solar performance relies on the principles of photovoltaics, which involves the conversion of sunlight into electricity through the use of solar panels. Here's a breakdown of the science behind solar performance. 1. Sunlight and photons. Sunlight consists of photons, which are particles of electromagnetic radiation. 1. When sunlight reaches the Earth, it contains a range of wavelengths, including visible light and invisible ultraviolet, UV, and infrared, IR, radiation. 2. Solar panels and photovoltaic effect. Solar panels, also known as photovoltaic, PV, panels, are made up of semiconductor materials, typically silicon. 2. When sunlight strikes the solar panel's surface, the photons transfer energy to the electrons in the semiconductor material. 3. Electron excitation. The energy from the photons causes the electrons in the semiconductor material to be excited, allowing them to break free from their atoms. 3. This generates an electric current. as the freed electrons can move freely within the material. 4. Electric field and charge separation. The semiconductor material within the solar panel is intentionally doped to create a built-in electric field. 4. This electric field facilitates the separation of the excited electrons and the resulting positively charged holes within the material. 5. Collection of electrons. The electric field within the solar panel guides the free electrons towards one side of the material, typically the N-type layer, where excess electrons are present, creating a flow of electrons. 6. Conductive paths. Metal contacts on the surface of the solar panel collect the flow of electrons, providing a conductive path for the generated electricity to be extracted from the panel. 7. Direct current, DC, electricity. The electricity produced by solar panels is in the form of direct current, DC, which is a unidirectional flow of electrical charge. 8. Inverter and alternating current, AC. To make the solar electricity compatible with standard household electrical systems, an inverter is used to convert the DC electricity into alternating current, AC, electricity. 8. AC is the form of electricity commonly used for powering household appliances and transmitting electricity through the grid. 9. Solar panel efficiency. The efficiency of a solar panel refers to its ability to convert sunlight into electricity. 9. Efficiency is influenced by factors such as the quality of the semiconductor material, the amount of sunlight absorbed, the design of the solar cells, and the temperature at which the panel operates. 10. System performance. The overall performance of a solar system depends on various factors, including the size and orientation of the solar array, the intensity and duration of sunlight, shading, temperature, and system losses due to wiring, inverter efficiency, and other components. Understanding the science behind solar performance helps in designing and optimizing solar systems for maximum efficiency and output. Factors such as the quality of materials, proper installation, and maintenance play a role in ensuring optimal solar performance over the lifespan of the system. Voltage, the pressure of the electric world. Voltage can be thought of as the pressure, or force, in the electric world. It represents the potential energy difference between 2 points in an electrical circuit. In an electrical circuit, voltage is created by an energy source, such as a battery or a power plant. The voltage pushes the electrons from the source through the circuit, allowing electrical energy to be transferred and used for various purposes. The unit of measurement for voltage is the volt, V. Common examples of voltage levels include household electricity at around 120 or 240 volts, batteries with voltages ranging from a few volts to several hundred volts, and high-voltage transmission lines that carry electricity over long distances at tens or hundreds of thousands of volts. It's important to note that voltage alone does not determine the amount of current, flow of electric charge, in a circuit. The current depends on the resistance of the circuit as well. According to Ohm's law, I equals V, R, where I is the current, V is the voltage, and R is the resistance. Amperage, understanding the flow of electricity. Amperage, also known as current, is a fundamental concept in understanding the flow of electricity. It represents the rate at which electric charge, electrons, flows through a conductor in an electrical circuit. Amperage is measured in amperes, A. 1 ampere is defined as the flow of 1 coulomb of electric charge per second. A coulomb is a unit of electric charge, and it represents approximately 6.24 times 10 to the 18 electrons. The flow of electric charge is driven by voltage, which provides the push or electromotive force that propels electrons through a circuit. Higher voltage creates a greater potential difference and can cause a higher rate of charge flow. It's important to note that wattage alone does not indicate the quality or efficiency of an electrical device or system. Factors such as power factor, energy efficiency, and overall performance should also be considered when evaluating the effectiveness of electrical systems. And that's a wrap for today's video on mastering battery bank installation for off-grid systems. We hope you found this guide helpful and informative. Remember, Proper installation and maintenance of your battery bank are essential for safe and efficient off-grid energy systems. By following the considerations we discussed, you'll be well on your way to unlocking the intricacies of battery bank installation. If you have any questions or want to share your experiences with battery bank installation, please leave a comment down below. We love hearing from our viewers and building a community of like-minded individuals passionate about sustainable energy solutions. Don't forget to hit that like button and subscribe to our channel for more informative videos on renewable energy, and we will try to get back to you on more DIY projects and sustainable living. And remember to click the bell icon to receive notifications so you never miss an upload. Thank you for joining us today. If you enjoyed this video, please give it a thumbs up and share it with others who might find it valuable. Together, we can make a difference in promoting clean and reliable energy solutions. Stay tuned for our next video, a continued series of 10 videos in this project, where we'll dive into more exciting topics of mastering battery bank installations and so forth, and explore the fascinating world of sustainable energy. Until then, take care, stay curious, and keep harnessing the power of the sun.